I would say, kind of to Max's point, is I think many of these are complicated. And when you have two or three or five systems, there are so few people that are experts at any one of those systems. It just becomes very difficult. I chatted with a group kind of at the beginning of the pandemic who kind of found this strange niche in building a software platform that allowed people to do a better job just specifically on their welding robots, because they find a lot of people buy welding robots and then they can't actually get the welding robots to do welds that will pass inspections.
Yeah.
And so
Yeah.
they found it was a super simple overlay of a screen, but they found that if they go and kind of set the robotic arm up correctly, they can let you punch in, your 4 or 8 actual pertinent points of information, and then the robot can weld. And so I think simplification, whether it's through PLCs, whether it's through standardized libraries, whether it's through more people have a better understanding about how to use these specific robotic languages, I think we need to find a way to simplify more in order to do a better job pushing robots out into manufacturing facilities and then implementing them successfully.
Yeah, and I think that, my only add on to that is that we need to, I think, focus on what I would call targeted simplification. Because if you have a robot, you just try to dumb down everything. Congrats, you just stripped away all the functionality of the robot. You can now go from point A to point B, right? I mean, we can do a whole lot more than that now. What you need to do is have like application specific simplification. So, and this is the job of engineers in general, right? I mean, this is like my job. This is a job of robotics engineers the world over, to try to find ways to make systems usable to people that aren't robotics engineers. But if you start pulling away all of the complexity, then you also lose all of the functionality. So you have to find that balance somewhere in there, especially for the use case that it works very nicely. And for PLC based systems, I think that right now we have a very good balance for simple use cases. So a very good balance for pick and place use cases, a very good balance for integrated inside, for use cases where a robot is integrated inside a machine and is basically used as a positioner. Whereas, we might not have a very good balance yet for cobots or for, let's say, friction stir welding robots, right? I mean, there's certain levels of complexity that are beyond the scope of what we can do with PLCs right now. And some of those are beyond the scope, like you mentioned before, of what we can do with the controller that comes with the robot. I mean, there are some companies that say that your level of precision you can get out of that motion controller is not good enough for me. I need to, if I'm doing milling on the end of a robot arm, I need a better controller than what you gave me, right? So